Hello everyone. This is a small demo of how an Apache Spark framework can parse through a kind of big data and figure out how many occurrences are there for a particular word. So this is already a sample kind of demo which you might have seen in multiple places. I just wanted to share whatever learning I have got from here. So I have a file which is kind of having all the data related to a particular food as well as their corresponding calorie values. Like for example, in here I have this yogurt, vanilla. So there is this yogurt which is having vanilla flavor and it's kind of a non-fat. You might have seen that this across multiple malls or whatever the shopping centers, and the corresponding fat values, protein values are here. So this is kind of the big data that I have, and something related to a search feature, something like CRM. If I am looking for, so it should actually tell me that okay, there are 6 or 7 occurrences of CRM, and it should actually identify all of them in very quick time. So in order to demonstrate this, I have this small Java code which actually takes the input file, which is in this case is my uh, big data food file, and it actually initializes a Spark configuration. Now, this particular configuration suggests that, okay, my app name is simple application. You can have n number of kind of configuration here. Like if I just annotate it and I can show you, you can actually set the master of this particular Spark configuration. Master will be decided on where the your master node will be, those kind of stuff. So you can go in details. This is the Spark context. We will be using this Spark context to parse the file, create different processes, go through each chunk of file and compute them, and eventually every computed results will be collected to a single kind of result file. So this Spark context can be defined with different configuration, and one of the most important configuration is that of a yarn configuration. So you can set up your yarn cluster first. You can have your master node, which is the resource node, and the resource manager, and your child nodes with the node managers. And let's say if you have 4 node managers and you want Spark to run on all those 4 nodes, you can tell the Spark context that where is your yarn cluster, what is the configuration of your yarn cluster, and you can execute on them. The next part is the Java RDD. This is the resilient data center dynamic. I believe it's dynamic data center. Just correct me if I'm wrong. So this is the statement where I'm actually constructing the resilient data set, dynamic data set kind platform, which actually knows that okay, this is the file, and now it will take that file and it will distribute itself. Let's say if it has a 5 node cluster, so it will distribute that big data into 5 chunks of small data. Then each node will process this chunk of data, and then it will compute the results, which actually will be reduced to a consolidated result. So one another fact. So if you browse latest versions of Apache Spark 1.6, people are trying to move towards data set rather than RDD. Now, why that they are doing? Because there is a huge computation saved kind of feature in data frames. Now there are three features that you should keep in mind. One is RDD, the other one is data frames, and the third one is data set. You will see that the computation time, the CPU time taken by RDD is comparatively very much higher than a particular data set computation. But most of the algorithms, as data set is coming, growing by and by, most of the machine learning algorithms are getting converted into data set, but they are already in RDD. So those are some of the things because of which still we people are using RDD. So here the RDD context is getting set, and then you are trying to filter the log data, the huge big data, based on a kind of filter criteria where you are mentioning that I want all the uh, occurrence of CRM here. So that's the minimal kind of code that you need to do for a huge file having CRM. And now if I can show you how it works out is like, if you have you need to download Apache Spark, the latest one. The latest stable one is 1.6. You need to uh, invoke the Spark submit executable. You need to tell what your class is. In this case, my class is simple app, and your master will be having 4 threads. So here you are mentioning the number of threads that you want to have, and then you are giving the corresponding jar file, which will have all your files, the class files. So if I execute this, it actually throws error. Well, the error seemed to be have it was kind of, I was doing some edit modifications and I forgot to save the file, and because of that there was this error. Let me try it again. No success this time also. Let us see what's happening. Okay, so it seems that I was trying to compile my old code. So first I need to call ambient package so that it actually builds my current code, and then I should actually call Apache Spark to execute that particular code. So now it actually did the compilation part. Hopefully it runs, and I think this time it didn't throw any exception. I will just maximize this window to show you how much time it takes to compute that whole big data. So it took just 1.6 seconds to figure out the occurrences. Now this is kind of, as I told you, that this is a very simple example. You might have seen it in n number of places, but this is what I got from my learning phase. Hopefully, I can come back with more examples which are kind of real time example. The intent of this particular demo was to show you how from a Java code we can invoke a Spark cluster, and we can schedule all those jobs so that it uh, can give us the intended results. Now this works in Java, so I believe my next learning phase is how this particular code can be deployed in a Heroku node so that the service is always running. And then the client will just invoke the service which is running on Heroku node. So till then, hope you like this video, and till next time, uh, take care. See you.